Hello, welcome to Q-SYS Control QuickStarts. My name's Jeff Perkins. I'll be your host today. In today's episode, we're going to attempt to demystify the event handler. In this episode, you can expect to learn that changes of state will trigger the event handler. Additionally, trigger buttons, although they essentially have no state, always trigger the event handler. And lastly, the event handler responds to external stimuli but ignores internal stimuli. That's actually a really good thing. The key idea is that the event handler is an internal mechanism of a control that triggers the execution of a function in response to external stimuli. I know that's a mouthful, but let's get started. Let's close this and let's open this thing. So in Q-SYS, as I get this open, there are 4 different kinds of buttons, and each button does its own kind of thing. Stand by, this thing's taking a sweet moment. Okay, split the screen, shimmy that, bring this over. So 4 different kinds of controls. We have, and I have them here, we have the toggle button, the momentary button, the trigger button, and the state trigger button. And for our purposes today, I've configured the state trigger to have values 1 through 4. Now, with that, let's emulate and let's talk about how these things actually work in relation to the event handler. As I was saying, there are 4 different kinds of buttons. And here I have some very simple event handlers. Basically, every time I poke the button and the event handler goes off, I'm going to print the Boolean, the value, the position, and the string. It'll take a little bit more to work through the state trigger, but you've already seen a video on state triggers, so you know they're a little more interesting. But our 3 basic kinds of buttons, toggles, momentaries, and triggers, they all work we're very comfortable with them because we have a lot more experience, and that's fine. Let's talk about what happens. The toggle button is really, it's purpose-built to be things like mute buttons, etc., because of the way that they work. Effectively, what happens when I press the toggle button, and here we go, tick. When I press it, its Boolean state flip-flops, and it goes from false to true in this case, and the value goes to 1, and the position goes to 1, and the string becomes true. If I click it again, its Boolean state flip-flops. The value goes to 0, the position goes to 0, and the string becomes false. The way the toggle button works, and this is what we mean when we say button action type, is that toggle buttons toggle. They just do. You don't have to do anything extra. You poke it, it will flip-flop its Boolean state. And every time its Boolean state flip-flops, it triggers the event handler, as we've seen here. We'll do it one more time. It's currently off. When I click it, the Boolean becomes true, and then we are able to print, right? So I pressed it, the Boolean became true, that tripped the event handler prints out, Boolean is true, value is 1, position is 1, string is true. One more time, I press it, the act of pressing it causes it to flip-flop to false. The event handler recognizes the change of state, the event handler then starts printing out lines 2 through 6 like we were discussing here, and we get false, 0, 0, and false. Just like we expect. Toggles work like your car, right? You poke the button, car turns on, stays on. You poke the button, car turns off, stays off. Works like a mute button. Press the mute button, audio passes. Press it again, audio doesn't pass, etc. Okay. Secondly, we have momentary buttons. Momentary buttons work like this. When I press them, they flip-flop their Boolean state, and here we are. I press it, and I'm still pressing it. My finger is still on the button. It has flipped states. Its Boolean is now true. Its value is 1. Its position is 1. Its string is true. And now when I let go, it flips to false. The Boolean state changes. Event handler gets tripped again. We print out lines 10 through 14, and we see that the Boolean is false, the value is 0, the position is 0, and the string is false. One more time, when I press it, it flips to true, and when I let go, it flips to off. Momentaries only work while you're poking it. As soon as you let go, it flips back to off. These are really good in Q-SYS for things like when you want to ramp things, right? While pressing, it's true. When you let go, it's false. Super duper. I think PTZ cameras work like this. Ramps on game blocks work like this. And in the real world, you can think of your car horn. It works the same way. As you're poking on your car horn, it's making noise. And when you let go, it stops making noise. This is how that kind of works. All right, let's look at the next kind of button. The next kind of button is the trigger button. And same thing, we're going to print the Boolean, the value, the position, and the string. And I click it, and notice, it only does one thing. When I press it, it trips the event handler. I press it again, trips the event handler. Press it again, trips the event handler. But notice what's happening. Its Boolean is always false. Its value is always 0. Its position is always 0. And poor guy ain't got a string, okay? Trigger buttons do one thing in life. They trigger the event handler. And that's why they're called trigger buttons. They just say go. Trigger buttons trigger the event handler. And that's all they do. But they don't have a change of state. So that makes them interesting. They simply trip the event handler, and the event handler does whatever you've told it to do. So that makes them curious. Which brings us, of course, to the last kind of button. And here it is, the state trigger. Again, we have a video on it and applications for it, and it's fantastic. But here's a very short rundown of it. State triggers are trigger buttons. They're just pure and simple trigger buttons. All they ever do by pressing it, right? The native action of the state trigger when you press it is it's just a trigger button. It just makes the event handler go. But state triggers also conveniently we're able to do fun and interesting things with their dot value. So here, let's look at this code for just a moment. The event handler here, lines 36 through 43, look very similar to what we've already been doing, right? I'm just printing the Boolean, the value, the position, and the string. Okay, but I also have this function called update value. And every time I press the event handler, I am updating the value of that state trigger. Here it is, line 37. The button's value is being updated by passing in the value to func update value. And then, well, up here, let's look at this function. I pass in the current value. I call it arg state trigger value. I increment it here in line 29. I then do a little checking to make sure that I haven't overrun the top, because if I get to 5, I need to reset it back to 1, make it go back down to the bottom state. And then when we're all done, we return the value. Yeah, functions in Q-SYS can return values. I know you don't see, you haven't seen us do a lot of that, but it totally works. And here is a perfect example of it. And so here's how this thing works, right? So out of the gate, the state trigger, because we defined it to be 1 through 4, it's starting with a value of 1. So when I press this thing, I would expect it, right? Line 36 to execute, because triggers trigger the event handler. The next thing will happen is line 37. So line 37 is actually going to run the function. The function is going to increment us up to 2. And then it's going to return the value of 2. And then we're ready to print out everything. So let's see how this thing works. There it is. Oh, I'm pressing the wrong button. I'm sorry. Hey, this thing's filmed live, so accidents do happen. State triggers. Here we go. Ding. There it is. So notice, We did indeed update our value to 2. Our string says that its value is 2. And the position says that it is basically 1/3. And our Boolean value is set to false. Interesting. Let's click through this a few more times. Click, click, click. All right, so there it is. There's the whole cycle. We pressed it. We went to value of 3. That made the string be 3. That made the position be 2/3. And that made the Boolean be true. I press it again. The value goes to 4. The string goes to 4. The position goes to 1, right? Which is 100%. And the Boolean goes to true. Cool. And then I press it one more time. We reset it back down to the value, the minimum value, because we're just stepping through in this particular situation. The position goes to 0, the string goes to 1, and the Boolean goes back to false. So here's what's happening. State triggers are triggers. They just triggered the event handler. That's all that's actually happening by the actual poke of the button. However, programmatically, we are doing interesting things with its dot value. And that dot value, as it changes, its position is changing. And as soon as the position crosses 0.5, right, 50%, then that Boolean becomes true. Now, we can't really rely on the Boolean to do logic the way that we can for momentaries and toggles, but that's because we have multiple states. So we really need to run our logic on our projects through the value and figure those things out. Now, all that being said, right, what have we seen? Toggles, you poke it, it changes state, triggers the event handler. Momentaries, you poke it, it changes state, you let go of it, it changes state. Each of those triggers the event handler. The trigger button, boop, just makes the event handler go off. There's no change of state. It just says go, go, go. The state trigger, in the very much the same way, just tells the event handler to go, go, go. But we can do interesting things to get, we can model a variety of states with state triggers. Now, there's more to know about state triggers. So hit F1, go to the help file and read more about the intricacies of this behavior. But this is the big idea, and you now have it. Okay, that's enough about that. Let's close this and close this. And let's take a look at this guy. All right, this is a script that you've actually already seen if you've been with us here on Q-SYS Control QuickStarts. We have another video on interlocking buttons, and this is effectively the same little script. I've cleaned up line 11 here to make it a little more clear about what's going on. So let's poke some of these buttons and see what's happening. Currently, you can see that button number 1 is high. It's true. Its Boolean is true. When I press button number 2, what I would expect to see happen is I would expect for its event handler to go off. That means line 11 is going to run, and we're going to see that it was button number 2 that becomes true by us poking it. Then we're going to run through the function called interlock. And I have turned on lines 3 and 5. They weren't on in the previous video, so that we can see what's happening as we do that. So let's do that. Ding. So there it is. As I told you, we see that it's button number 2 that becomes true right here. Ding, ding, ding. Button number 2 became true. And then let's step through the loop. So we call the function. The function starts obviously with 1, and 1 started as true and then ended the loop as false. Remember, what are we doing in line 4? We are simply comparing. We are setting that particular Boolean, that particular control's Boolean, to be the output of the comparison between what position are you in the loop, I, and are you the button that was pressed, i.e. the CTL that is on, okay? That's the argument we're passing in. So button 1 started as true and ended as false. Button 2 started as true and ended as true, which makes sense. And then 3 started as false and ended as false. No problem. one more little thing to think through. Okay, let's keep going. Press button 3. We see the same thing. 1 started as false, ended as false. 2 started as true, ended as false. 3 started as true, ended as true. And go back to 1, and it's doing exactly what you thought it was going to do. Now, as we mentioned previously, and as you're probably looking at this right now, you're probably saying, hey, there's some weird things happening, I think. You said this is interlocking, but it sure looks like there are 2 things true at the same time. And isn't that a problem? The answer is, yeah, you're right to observe that. You are absolutely right to observe that, right? One more time, we'll step through it. Turn number 2 on. 1 started as true, ended as false. 2 started as true, ended as false. That means that for that long, 1 and 2 were true at the same time. Hey, Jeff, isn't that a problem? Come on, Perkins. It is in other platforms, but it's not in Q-SYS. Other platforms have a fundamental analogy of electromechanical circuitry, in which case, if you indeed have 2 connections, electricity will flow down both of those wires at the same time, and that would be bad, right? That would necessitate a need for breaking before making. In Q-SYS, we don't have to do that. There's a really, really good reason for why we don't have to do that. Namely, it turns out that the event handler is written in a clever way. It's written to know whether the change of state comes externally or whether it comes internally. And the event handler ignores internal stimuli. Here's what I mean, right? This is a change of state, isn't it? Button 1 changed from true to false. Well, that's a change of state. That ought to trigger the event handler. What's going on? I'm telling you, the event handler is smart enough to know the difference between external and internal stimuli that's changing the state, and it ignores the internal. That's why we don't see the event handler for button 1 going off again. All right, let's intentionally break some things to see how this works. I'm going to go offline for a moment. Okay, I'm going to open this particular script, and you'll notice this script is 100% the same as the script that we were just looking at, except for that I add line 18. Line 18 is simply guaranteeing that when I start the script that button number 1 is low. And let's do some things. 1, let's wire on these pins, let's wire the output of 1 to the input of 1. Let's also do something wild and crazy, like output button 2 into button number 3. And we'll do that right there. Let's hit go, and let's sort out what's happening here. So here's our buttons. Here's our buttons. Okay. Let's check our logic. Let's check our expectations. Button 1 is currently low. When I press it, I would expect for line 11 to print and to see that its value, that its Boolean becomes true because I pressed it. All right, that's what we should expect. And let's go. Ding. And there we are. All right. And if I press it again, here's what I would expect. Because toggles toggle when I press it, I would expect to see line 11 print and say that button number 1 became false when I pressed it. And then we run the loop and we turn that light back on. Okay. Ding. This is exactly what we saw. When we pressed it, button 1 became false and we hit the loop. When number 1 goes from false back to true. And then 2 and 3 started false, stayed false. That's fine. They're not really part of the story at the moment. What's happening with that pin? That pin goes true. And true comes out the pin, goes around the tree, around that wire, and then back in the hole as true. And so we have true coming in on the pin, and then there's a comparison made. All right, true's coming in, and then there's an evaluation. The event handler goes, oh, I see a true coming in on the pin. I'm already true. Okay, I'm good. No problems. Okay, all right, so that's half the story. Now, let's do something a little bit wild and crazy. Let's press this button. Here's what we should expect to see. We should expect to see that line 11 prints and says button 2 became true. We run the loop. We turn off number 1. We make sure number 2 is on, and we make sure number 3 is off. That's the end of the loop. But that's not the end of the story. What also we should expect to see is that true comes out of pin number 2, goes around the tree and back into hole number 3. So now number 3 sees true coming in. Number 3's event handler then goes, okay, I got true coming in. I'm currently false. Hey, that's a change of state. Okay, let's go. Event handler runs. Button 3 becomes true. Button 3 becomes true. Is what we're going to see. Line 11 will print. Button 3 became true. And then we'll see it run through the loop, and it will make sure number 1's turned off. It'll turn off number 2. It'll make sure number 3 is turned on, and that's fine. But that's also not the end of the story, because when we turn off number 2, that off comes out of the hole, around the tree, back into the hole. And now the event handler, right, the pin comes in as 0, as low on number 3. And button 3's event handler looks at it and goes, oh, I got a false coming in. I'm currently true. Oh, I should flip, I should turn off. And so we'll see the event handler go off one more time saying that button number 3 became false. And we'll run through the loop again, make sure everything is off and button 3 is on. Are you ready? Steady? Let's do it. I pressed the wrong button like a dum-dum. All right, button number 1. All right, here we are. Now we've reset. Again, this is live. Okay. Button number 2. Here we go. Ding. All right. There we are. So remember, we pressed button 2. 2 became true. Ran the loop. Everything was fine. 2 came out. Ran around. Oh, that makes 3 go high. Make everything turn off. Oh, but turning off number 2 meant that we sent a false from 2 back into 3 because of the way we wired it. And then that made the event handler for 3 go off again. Okay, you see how the event handler works? The event handler does exactly what it's supposed to do, which is this. It ignores internal changes of state. It responds to external changes of state. And sending in things through pins count as external changes of state. Time out. Let's make sure something's clear. Let's step through this one more time super slowly. Here's what we expect to have happened, and this is what we see. When we started, 1 was true, 2 was false, 3 was false. When I pressed button number 2, toggle's gonna toggle. It's gonna flip from false to true. And then we're going to run into our loop. The loop is looking for changes of state. It's looking to make sure that whichever button had its event handler go off is the one that has its light on, i.e. its Boolean be true, which means when we step through, boop, 2 became true, and then we see right here, we see that 1 went from being true to being false as we run through the loop. 2 started the loop as true, ended the loop as true, and 3 started the loop as false and ended the loop as false. Fine. And then as I said, true on pin number 2 comes out, goes around, comes back in on number 3. Number 3 sees true come in, and it does the comparison. True coming in, internally, looking, oh, I'm false, and so toggle's gonna toggle. 3 flips from false to true. It becomes true. And then we see that we go into the loop. We run through, we check, 1 is false, and it's false after we're done. 2 went from true to false because of the way the loop works. And then 3 started the loop as true and ended the loop as true. And then one more thing happens. This false, right here, this false comes out of 2 and around into 3. And because toggle's gonna toggle, when false comes in on pin number 3, it looks inside of itself and it says, oh, false coming in, I'm true, I should toggle and become false, which triggers the event handler, which we see right here. This is line 11 printing out, and then we go into the loop. 1 started the loop as false, ended as false, true started as false, ended as false. And this is the tricky thing. 3 started the loop as false, but because the way our function works here, it sees that the event handler happened and it turns itself back on, which is what we expected, which is what we see. And this is just the event handler doing its thing. Okay, time back in. Okay, one last thing. Remember in Ghostbusters, they tell you don't cross the streams? Because, well, what would happen if you cross the streams? Well, just imagine life as you know it exploding away from itself at the speed of light, right? A total protonic reversal. Let's cross the streams. We're offline. There we are. We have now crossed 2 and 3. This is not like a serial connection where you're supposed to cross pins 2 and 3. This is going to be the end of the world. Here we are. Doesn't matter which one. All right, we pressed number 1. That's fine. That clears the system. And go. Yeah. Yeah, this isn't great. But this is completely expected. Completely expected. 100% consistent with expected behavior. And this is kind of an infinite loop. Yeah, kind of. So what's happening, of course, is we're sending values out pin 2 into pin 3, out 3 into pin 2, and they're just, the code is just cycling. So is it an infinite loop? Yes, sort of. It's not crashing out because it's all happening in a timely fashion. So it's okay from that standpoint. The reason I'm showing you this is not because this is bad and this is something, I mean, it is bad and you definitely want to avoid it, but this is the kind of thing that if you're using pins to drive logic and if you're not careful and you have, right, you start dominoes over here and you send signals all the way through and then you like run a signal back to the front. If you're not careful, you could do something like this and it would look like this. And so if you ever find your system doing something like this and you're like, what the heck's going on? Check your signal flow. Check to see if you haven't accidentally programmatically caused things to be related to each other and then cross the wires, right? It wasn't good in Ghostbusters. It's not good in Q-SYS. It's not good in the real world, really, in any situation. So be mindful. Now, we're going to stop that because that's fine. I mean, this code will keep running. It'll run forever. It's not a problem. It's not crashing out or anything. It is doing exactly what we asked it to do. It's just what we asked it to do is something we should not have asked it to do. I'm going to close that, and let's wrap this up. Let's land this airplane. So what did we learn today? We learned how the event handler works. Basically, it's looking for changes of state. That's really what it's doing. It's looking for changes of state. The trigger buttons are special insofar as they really don't have a change of state. They just make the event handler go off. That's why they're called triggers. Triggers, trigger, right? Think about that. Triggers, trigger. So the big idea is that event handlers are internal mechanisms that trigger the execution of a function in response to external stimuli. Thankfully, not internal, because that would truly be a total protonic reversal. But with that, hope you have a great day, and we'll see you real soon. Bye-bye.